Okay, section 4.2 is even and odd function. So we have to determine which one is even and which one is odd. So you just need to know that if even function, meaning that when you substitute negative x into the function, so if you get fx, meaning that this one is even. And then if you substitute negative x, if you get negative fx, meaning that this one is odd function. Okay, for example, fx is equal to x cubed. And then you substitute negative 1. So you will get negative 1 power of 3. And then you will get here is negative 1. So this one is meaning that f negative x is equal to negative x cubed. So this one is odd function. Okay, this is example. Let's say fx is x squared. And then you substitute negative 1. So you will get negative 1 squared. And then you will get here is 1. So meaning that f negative x is equal to x squared. So this one is even function. Okay, and then we can say that one more is the graph for even function is symmetrical about the y-axis. Okay, for example, this graph, y with respect to x and then y to x squared. So you get like this. So this is fx and then this is f negative x. So this one is symmetry. Look at the even our function. Let's say you add f negative 1. So negative 1 and then you will get 1. And then if you substitute f1, you also get 1. f1, so you get 1. So this is symmetrical about y-axis. Okay, then how about the odd function? Let's say you have x cubed. So you will get like this. Okay, when you substitute negative x, let's say f negative 1, so you will get negative 1. So let's say here, so you get this point. And then how about fx? f1 is 1. So the point is here. So meaning that this one is not symmetry at y-axis, but this graph is symmetry about origin. One more tip to know this graph is symmetry about origin is when you rotate 180 degrees, you will get same pattern. Okay. If none of 1 and 2 are satisfied, then fx is called neither even nor odd function. Okay. Okay, now we want to look at example 3, determine whether the following functions are even, odds, or neither. So the first one is fx is equal to x squared. So what we have to do is f negative x equal to negative x squared. So we get x squared. So this one is fx. So this one meaning that even function. Okay, look at number 2. hx equal to sine x. Okay, hx equal to sine x. So h negative x equal to sine negative x. Okay, then sine negative x is, okay, how to know what is the answer for sine negative x? So you can assume that this is sine 0 minus x. And then what is the property for sine a minus b? You can look at the formula given to you. So sine x minus y. So meaning that sine x cos y minus cos x sine y. So you will get here is sine A cos B minus cos A sine B. So from here you will get sine 0 cos x minus cos 0 sine x. Okay, this one is 0. Then this one is 1. So you will get negative sine x. So this one is negative h x. So we can say that this is odd function. Okay, from the third question, example 3, gx equal to x power of 1 over 3 minus sine x. So g minus x equal to minus x 1 over 3 minus sine minus x, then equal to, so we will get negative x 1 over 3 minus sine negative x is negative sine x. So you will get negative x 1 over 3 plus sine x. And then negative, we factor negative outside, so we get x 1 over 3 minus sine x. So this one is equal to negative gx. Okay. So this is odd function. Okay, and then the last example is ft equal to e power of t. So f negative t, we will get exponent negative t. Okay, this one, exponent negative t is not equal to negative exponent t. So this is not odd function. And then this one, e power of negative t is not equal to et. So this is not even function. So the answer is, we can say that this one is neither even function nor odd function. Okay, under 4.2, even and odd function, you have 4.2.1, which is the properties of even and odd functions. So, for example, you have two functions, function 1 and function 2, which is even plus even, you will get even function. Okay, let's say x squared plus x squared, so you will get even function. And then let's say odd plus odd, you will get odd function. For example, x cubed plus x cubed, you will get odd function. Okay, then what happens if even plus odd plus minus odd function, you will get neither function. For example, fx equal to x squared plus x cubed. So you will get neither function. And then if even multiply or divide by even function, you will get even function. For example, fx is equal to x squared divided by x power of 4. And then odd multiply or divide by odd, you will get even function. For example, x cubed divided by x power of 5. Okay, this is example. So the last one is odd multiply or divide by even function, we get odd function. For example, fx equal to odd is x cubed divided by even, let's say x squared, so you get odd function. Okay, now we look at integral properties. Okay, integral properties is we want to know what happened for the integral of even function and integral for odd function. Okay, so for even function, let's say fx is even function, so you have this graph. Okay, this is fx equal to x squared. And then you will integrate from negative 2 to 2. Let's say that from L to L fx dx. You can say that this one is equal to 2 because you have 1 and 2 multiply with integrate from 0 to L. Okay, fx dx. So this is properties for even function. And okay, let us see, for example, fx equal to x squared. So we will integrate from negative 2 to 2 x squared dx. So what you can do is 2 multiply with integrate from 0 to 2 x squared dx. Okay, you have to change the limits. Okay, make sure you change the limits and multiply with 2. Okay, the integral of the odd function is we will get 0 from negative L to L fx dx equal to 0. Okay, for example, fx is equal to sin x, and then integrate from negative pi over 2 until pi over 2. Okay, so we have two regions. So the first region is from negative pi over 2 to 0. Okay, integrate sin x dx, and then the second region is from 0 to pi over 2, 0 pi over 2 sin x dx. So when you integrate from negative pi over 2 to pi over 2, you will get 0. This one is the integration of the odd function. Okay. Okay, we look at the simple example. Let's say fx is even function, and then integrate from negative L to L fx multiply with sine and x. So n is odd function, and then fx is even function. So as we discussed before, even multiply with odd, you will get odd function. Okay, you have to remember this, we did before in the previous example. Okay, next example is fx even function multiply with cos and x, which is even function. So even multiply with even function, you will get even function. Okay, so you have to know this one. Okay, next example. If fx is odd function, so odd function multiply with odd function, you will get even function. Okay, next, if fx is odd function and then cos and x is even function, you will get odd function.